Hi, as you already know by the title of this video, well yeah, someone did crack my game, and as usually is the case with cracked games, they modified the code, they added a small demo at the beginning of the game with some messages and music. Well, you know how that goes, right? Now, although the story behind this crack is very strange, the main purpose of this video is to show you how they actually improved my code and what they actually did to make the game run faster. So if you don't want to listen to this crack story, this video is divided into chapters, so you can skip this part. Now, the crack story. So some time ago I made a little series of Pong games for Commodore 64. The first one was written in BASIC. It was called Mini Pong, and the whole idea was to see can I make a small Pong game in BASIC that runs smooth enough on Commodore 64. And the second one was written in C programming language, and it was Game of the Pong that runs inside the sprite. And that's the one that you see here behind me on the screen. And the third one followed the same concept as this one, also written in C programming language. It was called Micropong, and it was the Game of the Pong that runs inside the single Petsky character. Now, the one that got cracked is this one right here, and probably the main reason is because the video where I talk about this game got a lot of views, at least for my channel, so they kind of picked that up somewhere, right? So let me show you the crack and how that looks like and how that little demo they made. And just a little warning, there are some nasty parts, so I will try to blur some areas, but I will show you where you can download it so you can take a look at it in full glory. And then we can take a look at the code together. So yeah, let's begin. Okay, so this is the CSDB website, or the Commodore 64 Scene Database archive, and it's a very popular place for C64 demos and cracks of games and whatnot. Well, anything related to Commodore 64 really. And this is where the crack version of my game has been published, so yeah, let's try to find it. So it's called Tiny Pong. Now let's see. And here it is. So it's called Tiny Pong Deluxe plus J. I don't know what plus J means. And Deluxe should mean that it's kind of improved version, which it is. And then we have type, so it's published as a crack. And then we have this nasty thumbnail. So yeah, so there's several problems with this. The first of all, it's published as a crack. Well, it's not cracked. My game wasn't cracked because I never actually published just the executable binaries. I also published the source code, which I always do with any kind of project that I made. And it's not really a game. It was more like a demo. But yeah, okay, let's call it a game. So yeah, they published it as a crack. It's not crack. They had the source code and they changed the source code, which is fine. I absolutely agree with this, and I really actually enjoyed this because someone else took my code and improved it, which is absolutely great. And this is what we are going to take a look a little bit later. But the problem is that, you know, all this packaged all together, it doesn't really fit to one another. So the title doesn't fit with the thumbnail doesn't kind of fit with the type doesn't fit, you know what I mean, right? It's really unrelated stuff. So this thumbnail is actually part of the demo, which I will show you later, and there is messages that are addressed to me, and music, and yeah, I mean all these things together is just it doesn't fit to one another. It's just I don't know how to describe this this package and this crack. And yeah, but of course I didn't complain because they have absolutely right to do whatever they want. to me this is just funny. But I do mind because I tried to apply for registration for CSDB website several times. I was denied. And in the same time these guys can publish this kind of crap. So yeah, that's the only problem that I have with this. Otherwise, yeah, I love the artwork, it's just beautiful. Yeah. So yeah, let's try to download the game, or the crack version of the game, and let's try to play it. Oops. And the game is loaded, and here it is in its full glory. And as you can see, it's Mr. Ian Cook and Uber Team, or whatever they're called. And this nasty thumbnail, this is the whole demo, right? With these messages down below. It's a little bit hard to read with this effect, but all these messages are addressed to me. And here we go. Yeah, so I did some mess in C code, have no clue about assembler. Yeah, that's why human waste, that's another name mentioned in this demo. They need to bug fix it and almost recoded to include source code. Yeah, very sub-optimized. I didn't actually optimize that game at all. I was just having fun to play Pong inside the sprite. But yeah, okay. They gave me the joystick too. Thank you very much. Well, if you went through all this trouble to rewrite the code, which you didn't, but okay, then you could at least do a little bit better demo for this crack, because this demo is crap. This is the worst demo that I ever seen. So I don't know, maybe you can hire some designer to do it properly. Okay, let's play the game. And here's the game, and let's see, how do we play this? Oh, here we go. I hope that you can hear the sound in the game as well. Some sound effects. Okay, now the fun part in this game was when you start moving the sprite around and still play the game. So yeah, this was just fun for me to create back then. Whoops. Whoop. And it's very hard to play when you're moving arena around. Yeah. And also you can change the size, so this is just double size sprite. Yeah, it's a little bit easier to play. And as you can see, the ball is defined just as a single pixel inside the sprite. And we are going to take a look how they improve this movement of the ball. It's very smooth, it's very elegant, and very nice. So the technique they used, and I mentioned before assembler, yeah, it's technique they use to improve my code is very common to use in assembler. So we will take a look at that. Yeah, and here we go. I don't know how to play this anymore. Yeah. Okay, so this is the game, so let's take a look at the code now. So this is the code for the game. So this is my original code, and as you can see, it's written in C programming language, and I use CC65 compiler to compile it for Commodore 64. Now, like I mentioned before, they implemented the joystick control as well, but that's not really interesting, just peeks into memory location, nothing really interesting. So, but the thing that they change, and it does have a real impact on the game, is this part right here. So I have three functions here, and they're used to convert X and Y coordinates of the ball to find the memory position of a byte that we need to change, that is defined for that particular sprite. And not only to find exact byte, but we also have to know the exact bit inside that byte, because the ball is defined as a single bit inside the sprite. There's lots of videos on YouTube and tutorials who will explain you how the sprites are organized and created on Commodore 64, but just a quick reminder. So if we have our sprite area, and as you can see, it's divided into 3 columns, and each column for each row is represented by single byte. So this first row and this first 8 bits represent a single byte, and they're all zeros, so at the beginning we have 0. Now in this middle column we do have some populated bits. In that case we need to calculate the byte, and then it is 126 in decimal. And then again third column we have all zeros, and that's 0. Now here in the second row we have 2 populated bits, least significant bits, and that represents decimal number 3, and so on and so on. So we are going from top to bottom and from left to right. And these are the values that we need to store into memory of Commodore 64 in the predefined position for the sprite, and this is what will appear on the screen once we activate it. So if we want to create a ball or single pixel inside the sprite area, and we want to control it, this is how I made this. So we have X and Y coordinates, and that will give us single pixel, single dot inside that sprite, and those functions are there to convert those X and Y coordinates to find that particular byte, particular position in the memory of Commodore 64 for that particular sprite. And not only to find the byte, that's just one part of the equation, we also need to know exact bit inside that byte so that we can control it. So those functions are created to do just that. So we have 3 functions. Let me go back to the editor. So we have 3 functions. The first one is just to read the position, single bit position inside the sprite. The other one is to set that bit to 1, and the other one is to clear the bit or to set it to 0. But all of them share this logic which I wrote back then, and I actually never bothered to optimize this or to change it, but as you can see here, there is several mathematical operations happening. We have division by 8, then we have modulo, and then we have multiplication, and we have some bitwise logic as well. So the problem here First of all, it's this division right here. So dividing something is very CPU intensive. Modulo is also division, so that's the problem. Multiplication not so much, but also can be optimized as well. So let me show you what they made and how they actually simplify this and make it way better. So this is their code now, and these three functions are now looking like this. So from 4 lines of code and lots of mathematical operations, we are now down to 2 lines of code and no mathematical operations whatsoever, just bitwise logic and lookup tables. So they implemented the lookup tables instead of all that multiplications and divisions and whatnot. Now the point of the lookup tables is they are just arrays, and these are the pre-calculated values that are stored in the memory, so that we don't have to perform that mathematical operations that we need. We just use the index and pull the value from the memory, which is already there, pre-calculated. So that's the whole idea. And this technique is very common if you've done anything in assembly language. This is very common to use. It takes a little bit more space, but the performance is so much better and faster, of course. So let me go through these sections here and try to explain what's happening here. So this first part, they use this lookup table to multiply by 3. So I had this before, so I multiplied the y coordinate multiplied by 3, and they remove that. They pre-calculated all the possible values of y column, y-axis, and store it into memory, and they just use y as an index to pull the value out of the memory. Now the reason why this array is written like this, in this kind of form, I presume it's just for readability of the source code. During the compiling process, these values are calculated and they are stored as final values in the memory, so that's just fine. The only problem here, I don't know why did they go from 0 to 29, because y coordinates doesn't go more than 20 here. So this is like, I don't know, maybe they use it for something else as well, but I cannot see in this code any purpose for this part of the array. Yeah, so that's the first part. So we don't do any more multiplications, we just look into lookup table and we pull the value out. And now this part here, so they shift the x value 3 positions to the right, and that is the same as a division by 8. So luckily we have this division by 8, so it's even number, so we can do this. If there is some odd number here, we can use the shift method, but in case of the even numbers, we can just shift the value 3 positions to the right and you will get the exact result as division by 8. Of course, you will not get the decimal representation of the number, you will get the whole number. And this part is already making big difference in comparison to my code. And then we continue even more. Now this line here will give you a byte. So let me just show you once again that image. So yeah, it will give you the position of that byte, but we still don't have the exact bit inside that byte. Now, for get the exact bit, we need one more line, and this is this part right here. So instead of my crazy modulo by 8 and to get the remainder, it's much easier to get a remainder just by ending with 7. So what they did, it's a much more faster technique, also using a bitwise operator, and it will give you the same result. So just to show you which part is that, let me just try to color this. So it's this part right here. So this is what we need to get exact position, because this first part of the X value we already have built in when we found that specific byte in the memory. So the only thing that remains to find this exact bit, and this is exactly what this part of the code does. And then once we found that position, the value that we need to use for that byte is written in the second lookup table, and this is the bit tab table. It's this one right here, and as you can see, there is 8 values in there, and each value represents the ball at the certain different position, at the next position in that byte. So if you convert these hexadecimal values into binary, you will see that they're all zeros except one. One position is 1. So we use that values and we can move the ball through that byte in all X positions. Now this lookup table is used to read the byte, read the bit from that byte, and also to set the bit on that byte, so to write the position. And how to clear the position of that particular bit, they just did the inversion of that same lookup table. As you can see, there are same numbers, they are just inverted, and they use it for the clear function. So yeah, it's very nice technique, and it's very common in assembly language, and it's really nice to see it inside the C code, and it's actually really easy to implement it and to use it. And yeah, it to be honest, it makes really more sense to do it this way than my way with this. But back then I didn't think about this. I just had lots of fun doing Pong inside the sprite, and really didn't care about this too much. But there is huge difference in performance. Yeah, so if you take my game, my original game, and compare it to the crack version, this improved version, you will see that my version slightly glitches from time to time, but in this cracked version is just smooth and beautiful. So yeah, so this is all that I have for you today, and I hope that you enjoyed this little crack video on my expense. Yeah, I'll show you how dumb I am. But yeah, until next time, goodbye.